We are on set C, and I think we did the first 4 already, so we're ready for number, they're not numbered, but we're ready for the 5th one. And as I was walking by, I saw Parker Market false, so he's right, and I'm gonna let him explain why he thinks that one is false.
So I just kind of just did a little graphical on the side. It also says it's a sign, it's on the y-axis, so it would be x, which is what.
Think about this for a second. If theta equals 0, and you plug that into your equation, you're taking the sine of 0. What is the sine of 0? Sine of 0 is 0. So, wouldn't your first point be right here? Right? Not out here. If it were a cosine, you'd be out here. And your first petal would be there. But if it's a sine, you're at the origin. So then your next point is going to be, I don't know, pi over 3 or something, or pi over 6 or something. And isn't that going to make you be out here then? On the pi over whatever line? Yeah. So your first one is not at 0 when it's a sine. Because the sine of 0 is 0, so you'll be at the pole. You won't be making a leap. Remember, the furthest points out on your graph, the furthest point, it's not a picture, but the furthest point out on your graph is going to be where your equation is as big as it can be. What is the biggest this can be? What's the biggest that sine anything can be? 1. Isn't that how you have to read 4 units long? Now, when is this 1? This is 1 when the angle is pi over 2. And if the angle has to be pi over 2, then doesn't 6 theta have to be pi over 2? So where is that first leaf going to be? At pi over 12. Now, if you are a cosine, let's say it's this, the biggest it can be is where that is 1. Where is the cosine 1? At 0. So your first leap is going to be at 0. That's what a cosine is going to look like. This is what a sine is going to look like. Because with this problem, the first leap is at pi over 2, or pi over 12. Your leaves out here, this is where your sine and cosine are the biggest. And your sine and cosine are the biggest when they are 1. And sine is 1 at pi over 2, not at 0. Cosine is 1 at 0. All right, so good job, Parker. False. The graph of 3 minus 5 sine will have a loop. This one's kind of a hard one. Did you look back at your pictures? I don't know that this is going to be an AP question. Look back at your notes, at the pictures you drew and the day you did them on your calculator. What observation did you make? First of all, that's a lima sign. You should know that. So it's going to have some kind of dent or loop. Do you remember what the rule is? Will this one have a loop? Doesn't it have a loop when the number hooked to the cosine or sine is bigger? Look at your pictures. Some of them have dents, some of them have loops. Some of them have dents at the origins or the poles, some of them have dents other places. Doesn't this one have a loop? so yes, it will, true. But what are some other observations we can make about it? It's gonna be up and down, right? It's gonna be looping up and down. Is it gonna be looking, do you think it's gonna be looking, okay, so it's not a loop. I'm such a bad drawer. Okay, so it's got a loop like that, or like this. I'm terrible. Everything in my life is dependent on this. Okay, so it's gonna be one of those, right? How do I know it's one of those? Because it's a sign? Sign? And what do we know about signs? They are reflections across the y-axis. If it were a cosine, same shapes, but they would be sideways. Now, which one of those do you think it is? Do you think it's the top one or the bottom one? Let's type it in on your calculator. I'm not a polar curve expert. I think it's the bottom one. Let's type it in and see, and then I'll tell you about how it is. Could be totally wrong. Let's see if it What made me think it was the bottom one? I think I was right. What made me think it was the bottom one? Because it was a minus. Right, that was a -5. So that made me think it was the bottom. The big deal there is it does have a loop and it is on the y-axis. Okay. All right, so that was a true statement. We'll have y-intercepts at 4 and -4. Here's our polar grid. Remember, you can think of this equation if I'm going to have y-intercepts, where do I need to be? On the vertical axis? How can I be on the vertical axis? How can I have a y-intercept? Theta equals 0. Wait. If I'm going to be here, don't I need theta to be pi over 4 or pi over 2 or 3 pi over 2? Does that make sense? So what happens if I put pi over 2 in there? What's the cosine of pi over 2? What's the cosine of pi over 2? 0. So wouldn't that give me 4? What's the cosine of 3 pi over 2? It's also 0. So that gives me 4. But that 4 is down 4 because it's 3 pi over 2. So on the y-axis, that's -4. That's true. That's true. Point here at 4, and I have a point here at -4 on the y-axis. On the y-axis. So that's a true. That's a true. Remember, if we're on we're talking about y-intercepts, we're talking about the vertical. So the angles would be pi over 2 and 2 pi over 2. The point on the graph that's furthest from the pole is this one. What do you think? True or false? False? Why do you think it's false?
Because it's on the pie.
Because what?
Because it's on the pie. It's on.
Okay, but let's think about that for a second. What is, so here's my grid. Circles there. If I put in pi, I have 5 minus 2 cosine pi. What's the cosine of pi, Caitlin? -1. So wouldn't this equal 7? 5 plus 2. So I think that's a true statement. I think that's a true statement. The biggest, well actually since it's minus, the smallest this can be is -1. It'll never be less than that. So the biggest that expression can be is 7. Perfect. It is impossible to have a 4-rose curve with 10 petals. Alberto's nodding. He thinks that's a true statement. Why? Alberto?
Says like if you have an odd number, it like stay the same. But if you have an even number, it like doubles.
Exactly. So the only way to have 10 petals would be to have your coefficient be 5.
Yeah.
If your coefficient were 10, you have 20. So you are right, it is impossible. So 1, 2, 3, 4, I got 5 on that page, did you? It's cracked the code, but I don't know what the code is, so oh well. Set D. All these questions are about one function. So this time, they're all about the same curve, which is 7 minus 4 cosine 3 theta. Number 1. Maximum distance that we can be from the origin is 7. Kind of just talked about that. No. What's the maximum distance we can do from the origin? 11? Right? Because cosine can be -1, and that would make 7 plus 4, 11. So that's a false. Everybody okay with that? F changes from increasing or decreasing. You're allowed to do this however you want. I'm going to get a quick graph up here. There's my midline at 7. My amplitude is 4. There's 11. 3. I'm in negative cosine. Let's start down here. What are my labels here? Let's make sure everybody followed along. So midline's at 7, everybody good with that? Going up and down 4 from that point. upside down cosine, period 2 pi divided by 3, which means the middle is pi over 3. And the middle of that is pi over 6. And the middle of that is 3/6 or half a pi. Okay. That changes from increasing to decreasing at pi over 3. No, at pi over 3, we go from increasing, oh yeah, true. That's exactly what happens. We go from increasing to decreasing, so that's what. Everybody okay with that? Does that mean? F is decreasing from 0 to pi over 3. Is our curve decreasing from 0 to pi over 3? What's our curve doing? 0 to pi over 3. Increasing? Going up? The minimum distance that a point on this curve is from the origin, or in rectangular coordinates, the x-axis, the minimum distance we are from the x-axis is 3. True. Now another way you can think about it is, look at your equation, you guys. The biggest this can be is 1. So isn't 7 minus 4 as small as you can be? 3. Yeah, so that's true. The graph passes through the point 5 comma pi over 9. If we plug in pi over 9 into our equation, can we get 5? That's the question. Well, what's the cosine of pi over 3? 3 times pi over 9. The cosine of pi over 3 is 1/2. 7 minus 4 times 1/2 is indeed 5 over 9 would be like in here. So there's 5 right there. That's true. From pi over 2 to 2 pi over 3, we are decreasing. Is the curve decreasing? Yep. There's a relative minimum at 2 pi over 3. True. With a picture makes this easy. The point, something pi over 6, represents a point at the origin. So let's plug in pi over 6 and see what we get. If we plug in pi over 6, what do we get? R is 7. We get this point right here. So if we plotted that on a polar, here's pi over 6. You'd be out here. You're not in the polar, you're not in the origin, so that's okay. Relative maximum at pi over 6. No. Points go clear out to 11. Alright, so I got 1, 2, 3, 4, 5. You got 5 on that page too. I'll have to go back to my notes and see if I have the code somewhere. I got 4, here we got 4255. Is that the code you came up are gonna do some review. Okey-dokey. Now, we just reviewed a whole bunch a few days ago. So the only thing new is the older stuff, all the other stuff we reviewed the other day. All right, here we go. Let's run through some polar stuff, just to make sure we got it, and then you can work with each other and find some other stuff to work on. Let's go through this polar stuff. Name 3 points plotted at 3, 4 pi over 3. So 3, 4 pi over 3 would be right here. It's on the 4 pi over 3 line, 3 units out. Can you name some other points? The first option has to have a positive R and a negative theta. It says in the directions. So what would be another name for that point with a positive R and a negative angle? What would that be? 2 pi over 3. How do we know it's 2 pi over 3? Because all the way around is 6 pi over 3? 2 pi? So if this is 4/3, this would be 2/3. Everybody okay with that? Now, we want a negative R and a positive angle. Charlie?
-3 is pi.
Perfect. Because when you change the sign, you just go right through the origin, right to the other side, pi away. Beautiful. Now, we want both negatives, so -3, negative angle. Now, Charlie said this was pi over 3. Yep, that's it. Everybody okay with that? Instead of going here, she went here. Beautiful. All right, A, describe that. What in the world is R equals 5? What does that even look like? I don't know who's talking about it. Oh my God. It's just the 5th circle out on your graph, right? Aren't these all the points that have an R value of 5? So that one is a circle centered at the origin with a radius of 5. 2 cosine theta. That one's also a circle. What's that circle look like? It doesn't look like that one. What's this circle look like? Left, right, top, bottom. Right to the right. So it looks like this. And that is 2. So the center is at 1, 0. And the radius is 1. Radius is 1. Everybody okay with that? Uh-oh. 3 minus 4 sine theta. Is that just like the one we looked at a little while ago? That one was 3 minus is it gonna be vertical or horizontal? Vertical. It's gonna have an interior loop. Like that. How about this one? Isn't that one the same basic shape? But it is oriented sideways? Now, stop and think about what we've been discussing. If cosine is 0, cosine of 0 is 1, won't we be clear out here at 7? Right? So doesn't this one go this way? Will it have a loop? It will have a dent. Where will the dent be? Well, if you put in pi over 2, what do you get? Don't you get 4? If you put in pi over, you're up here at 4. What if you put in 3 pi over 4 and you're still at 4, 3 pi over 2, you're still down there? What if you put in pi? Where are you if you put in pi? You're at 1. That's where your dent is. And what about the last one? 3 cosine 5 theta. What do we got there? It's a rose. You go out 3, and you have 5 petals. Right? Okay. What point is the furthest from the pole in this equation? We want to be the furthest from the pole. That shape is a rose, so there's going to be more than one answer. When are you going to be the furthest from the pole? What has to be going on? Doesn't that have to be 1? And when is the cosine of 1? At 0. So 1 point is the furthest from the pole is right here at 0. It's out 8. Now this is a rose, and it has how many petals? 3. And they're evenly spaced, which means they're how far apart? 2 pi over 3 apart. So if you have already figured out that the first one is at 0, won't the next one be at 2 pi over 3? And the last one will be at 4 pi over 3? And these are the points that are the furthest away because those are the ends of the petals. Do you see how we figured that out? All right. Number 7. We're going to do a few more together, and then I'm going to set you loose. So just relax. You're doing fine. You'll survive it. -5 pi over 3. This is r and theta. We want rectangular coordinates, which means we want x and y. Right? How do we find x? X equals? cosine and our sine. That's how we find x and y every time. So, negative 5 cosine pi over 3, negative 5 sine pi over 3. That's all there is to it. Converting is easy. That's all there is to it. What's the cosine of pi over 3? 1/2. So this is negative 5 times a half. So negative 5 halves. What's the sine of pi over 3? Root 3 over 2. So that will be negative 5 root 3 on 2. Which quadrant is that point in? Quadrant 3. But wait a minute. Pi over 3 is an angle in quadrant 1. What happened? R is negative. So we went from quadrant 1 to quadrant 3. All right, we have this equation. And you are finding the average rate of change on the interval from 0 to 7 pi over 6. First thing we'll do is write down, that will be R, even using those letters, R of 7 pi over 6 minus R of 0 all over 7 pi over 6 minus 0. Everybody okay? With the setup. So now we get to practice our unit circle stuff. We're going to plug 7 pi over 6 into this function. So R of 7 pi over 6. We're going to figure out what that is by plugging it in. So that's going to be 5 cosine 2 times that, which will be 7 pi over 3. Minus the sine of 7 pi over 6 squared. The sine squared. All right. 7 pi over 3. That's too big. Yeah, make it pi over 3. So this is really the cosine of pi over 3, which you just told me was 1/2. So we got 5 halves. Okay. What's the sine of 7 pi over 6? Oh my gosh, the gray hairs are just multiplying. 7 pi over 6. Quadrant 3, right? It's the pi over 6 equivalent. On my unit circle, pi over 6 is what ordered pair? Root 3 over 2, 1/2. Put that down here in quadrant 3. 7 pi over 6, they're both negative. The sign is negative 1/2. But I'm squaring it, so it's going to become positive 1/4. So I'm subtracting 1/4, so that's going to give me, I got 9/4 for that first part. Everybody okay? Right, now I gotta do the same thing, I gotta find R and 0. So if I put 0 in there, I have 5 cosine 0, I'm putting 0 in there. Minus the sine of 0 squared. Alright, what's 5 5 cosine 0. What's the cosine of 0? 1, so that's just 1. What's the sine of 0? 0. Square root. So minus 5 over 7 pi over 6. Negative 11/4 divided by 7 pi over 6. It's not pretty, but it is what it is. Negative 11/4 times 6 over 7 pi. Anybody get negative 33 over 14 pi? Well, I'd be interested to know if that's what I got on the answer sheet. That's what I got. Anybody see any mistakes? Lots of room for it, that's for sure. Alright, just a couple more. And then I'll sit there. Number 10. Number 10. We're finding the polar form of this number. So this number looks like this. Over 10 down 4. The reason I need a calculator is I'm going to need to know this angle, and these are not numbers that are on my inner circle. So I'm going to need a calculator to do that, right? So to find that angle, I'm going to second tangent 4/10. And I got 0.381. This is what was negative. You know what? The negative is handled by being in quadrant 4. I have a 0.381 angle in quadrant 4. So my theta has to be a quadrant 4 angle. It's going to be this one right here. How will I find that theta? I'm trying to find my polar form, so I need theta. How will I do that? 2 pi minus that answer. So theta is 5.903. Now what else do I need? I'm trying to change this number into polar form, which is r cosine theta plus I times r sine theta. That's my goal. That's what I'm shooting for. So now I know my theta. How do I get my r? Yep. So it's going to be the square root of 116. Which, since you have a calculator, you can get a decimal for that, or you can just leave it the square root of 116. We really needed a calculator for the angle. If you put a decimal, it would be okay. There's my polar form. All right. All right, there's a couple questions about graphs. I'm gonna let you sort those out. So right now, so 1 through 18, problems 1 through 18 on this little packet. You and your partner spend some time on the ones we haven't done yet, pick and choose, and we'll talk about the ones you have questions about. Okay? So let's take about, let's take about 20 minutes. So, get with a partner. I really want you bouncing ideas off of each other. Get with a partner.
So you're